Hi guys, today we're going to be looking at a free fall example. So we have three different questions here. The first one that we'll cover is how long will the ball be in the air before it hits the basketball hoop? Now to begin this problem, we're going to have to set up our coordinate system. So this is all a one-dimensional problem. So we're going to call the ground x equals 0. And we're going to say this direction is positive. Okay, so now that we have that, let's write out the equation that we're going to use to solve this problem. So, since this is a free fall problem, we're most likely going to be using the quadratic equation. So we'll have x final equals 1/2 acceleration times t squared plus v initial times t plus x initial. Okay. Now that we have our equation written out, we're going to set what our values are for each of these variables. I'll do it over here on the left where we have some space. So starting at the left, our x final. Now what's our x final going to be? We're not going all the way to the ground, so it's not going to be 0. We're going to the top of the basketball hoop, which is 10 feet. Next, we have our acceleration. Now our acceleration is due to gravity, so it's going to be negative because gravity acts in the downward direction, 32 feet per second squared. Okay, moving on, we have v initial. V initial is 0. That's going to be in feet per second. And then we have our x initial. And that's going to equal 46 feet. And that's because we're throwing not from the top of the building, but 6 feet above the top of the building. Okay, now let's write these terms in our equation. We have x final is 10 feet equals 1/2. Put this in parentheses so we don't get confused. 32 feet per second squared times time squared. Time is what we're trying to solve for. Plus 0 feet per second times t plus x initial, 46 feet. Okay, so we can get rid of this term right here to simplify. And we don't need to solve the quadratic formula for this example. We will need to in the future. So we're going to get t by itself here. So to simplify this, we're going to subtract 46 from both sides, minus 46. Minus 46. So we're going to have negative 36 feet equals, we'll do this 1/2 times this negative 32, giving us negative 16 feet per second squared times t squared. Okay, and now we're going to divide both sides by negative 16 feet per second squared. Now you'll see, if you don't understand this is totally okay, but feet divided by feet per second squared actually will give us seconds squared. So first let's do 36 divided by 16. That's 2.25, and since they're both negative, it's going to be positive. 2.25 seconds squared. And then over here, it'll just equal t squared. Now, you may be thinking, what is a second squared? It doesn't really matter because it equals time squared over here, which will also be in the units of second squared. Once we take the square root of it, that squared will go away. So we'll take the square root of both sides to get t by itself. Square root of 2.25 is 1.5. So equals t, and that's in seconds. So our final answer is it will be in the air for 1.5 seconds. Bam. Okay, that wasn't so bad. Now let's look at the next one. What about if we throw the ball at 3 feet per second downwards? Okay, so we're going to write out our equation again. It's always good to write out the equation for practice. X final equals 1/2 at squared plus v initial t plus x initial. Okay, now again, our x final is still going to be 10 feet. Our a is still going to be negative 32 feet per second squared. Our v initial, however, is going to be, what did we say, 3 feet per second downwards. We need to make sure we get that negative. Okay, and now we have our x initial, which is still 46 feet. Okay. All right, now we're going to plug all of this into our quadratic formula, and then we're going to need to solve the quadratic formula, which you can program into your calculator, and I highly advise you to do that if your instructor allows you to do that. If not, we can also solve it by hand. It's not too scary. Okay, times t squared minus 3 feet per second, because we have a minus, so I'm just substituting that right in, times t plus 46 feet. Okay, now, since we're going to solve this like a quadratic formula, we need one side to equal 0. So to do that, we're just going to subtract 10 from both sides, 10 feet. So now we have 0 equals, and I'll do this simplification like before, negative 32 times 1/2 is negative 16 feet per second squared, t squared, minus 3 feet per second, t, plus 36 feet. Okay, now on to the quadratic formula. So if you remember from your math class, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's write out what our a, b, and c is, and I'm just going to move this down a little bit, make it a little bit more secure there. Okay, so our a equals negative 16, our b equals negative 3, and our c equals 36. All right, because our a is the coefficient of t squared, our b is the coefficient of t, and our c is the coefficient of, well, it's our plane value. Okay, so now we're going to plug these in. We have x equals negative b, so that'll be positive 3, plus or minus the square root of b squared. Now if we're plugging this into our calculator, we need to make sure that that negative 3 is in parentheses. Otherwise, it's going to give us the wrong answer. Minus 4 times negative 16 times 36 divided by 2 times a. 2 times negative 16. Okay. Now, more realistically here, actually, I'm just going to real quick change these to t, because that is what we are solving for. So now I'm going to hop over to my calculator, and we're going to plug this in. Now I want you to do this with me, because this is a part where most people are going to end up getting it wrong. So we've got 9 minus 4 times negative 16 times 36, okay, and then in the denominator, 2 times negative 16. Okay, now you may get a negative value here. Now, so the first time I did it, when I plugged in my plus, I got negative 1.596. Now, this, we just know, cannot be correct, right? So we may be wondering what's going on. Well, there's really two moments, or two answers to this equation, one where you do plus, one where you do minus. So we're going to do the same thing in our calculator, except change that plus to a minus, and now we get 1.41 seconds. Okay, now this one makes sense, right? And this is because the quadratic formula is plotting a parabola, and at one point it must be crossing our x at a negative value, and the other one is a positive value. The positive value is the one we're interested in. So now that we have that, we have 1.41 seconds. Now let's think about this. Does this make sense? Let's do a little bit of a sanity check, right? So before we said it takes 1.5 seconds to get to the bottom. Now we're throwing the ball downwards. So would it take more or less time to get to the bottom? It should take less time because it's already moving a little faster. So 1.41 seconds will be our final answer for this guy. Oops. Will be our final answer for this guy. Okay, now let's go back to the top. How tall is the building if the ball is in the air for 2 seconds? Okay, now this one, there's a couple of ways that we can go about doing this. Here's how I would do it. I would say and we're also going to be discounting the fact that we're throwing it downwards at 3 feet per second. We're just going to say we're dropping it. Now, how I'm going to do this problem is we're going to figure out how far this ball falls in 2 seconds. We're not going to worry about any of this other dimension stuff. We're just going to say how far does it come from this point up here? How far does it fall in those 2 seconds? So it's going to be the same equation. X final equals 1/2 AT squared plus V initial T plus X initial. Okay, so X final is going to be 10, right? It's going to be 10. So we're going to be figuring out how much further above the ground it is than this 10. So X final is 10. Our A is going to still be negative 32 feet per second squared. Our T is going to be 2 seconds. Our V initial is 0, and our X initial is unknown. All right, so let's start plugging these things in. So we have 10 feet equals 1/2 times negative 32 feet per second squared times 2 squared, 2 seconds squared, plus 0 times 2 seconds plus X initial. Okay, now let's do some simplification here. So we're going to have, this is going to go to 0, and we'll have 10 equals, I'm going to do this 1/2 times negative 32 times 2 squared. So 1/2 times negative 32 times 2 squared. That's going to give us negative 64. Negative 64. And then we're going to have plus xi. Okay, now the way this all works out, right here, we have seconds squared, and we're multiplying them by seconds squared. So this unit is going to be feet. This unit's also still going to be feet. Okay, so now we're going to add 64 to this side. So we have 74 feet equals X initial. Okay, so that's 74 feet above the ground. But remember, we're throwing the ball from 6 feet above the top of the building. So let's draw a little diagram down here. Here's our ground. This isn't going to be perfect. Here's our building. Sorry about the not straight lines. And here is our basketball hoop. Very rough sketch here. Okay, so this is 10 feet. Okay, and the place where the ball was thrown was up here at 74 feet. There's our ball. And we know we're still throwing from 6 feet above the building. And we want to know how tall the building is. Okay, so to do this, we're going to take our 74 feet, and we're just going to subtract 6 feet from it. So 74 minus 6, 68 feet. That is how tall the building is if the ball is in the air for 2 seconds. Thanks for watching, guys. Please feel free to ask any questions in the comments if you still have any. Please like and subscribe if you found this useful. And yeah, thanks for watching.